Welcome back to our Chem 152 video series. In this video, we'll be reviewing Le Chatelier's principle and how it applies to acid-base reactions. Our reaction for this video is NO2 plus water yields HNO2 plus OH-. This is an acid-base reaction where NO2- acts as our base and it gains an H from water. Water loses an H and becomes OH-. Again, the NO2 that takes the H is the base, which means water must be the acid. Our first question asks, which way does the reaction shift if we add the following to the system? Part A says adding HNO2. The first thing you want to do, if you want to evaluate what happens, is try to locate HNO2 in the system. We can see that HNO2 is located on the right-hand side of the equation. And Le Chatelier's principle says if we add something, we react away from what we added. Because HNO2 is on the right, we will react left. Because left is away from HNO2. This means we will actually not make product, but get more reactant. Let's try the same thing for part B. Part B says to add KNO2. You might notice that KNO2 is not in the reaction, but NO2 is. To resolve this discrepancy, we'll need to remember that KNO2 is soluble because it is NO2 connected to a 1A metal. Therefore, we begin by breaking KNO2 into pieces. If KNO2 breaks into pieces, you'll have K positive and NO2 negative. The K positive is not in the equation, and so it will have no effect. NO2 is in the equation, and it is on the left-hand side. So we have added something to the left side. And because you always shift away from things that you add, because we added to the left, we will shift right. Shifting to the right means that we will lose our reactants and make more product. So if you're working a Le Chatelier's principle problem, always look for soluble compounds and look how the pieces of those soluble compounds can influence the reaction. Some examples of ways that you can affect acid-base equilibria are not quite as straightforward. At first glance, it would appear that adding AgNO3 would have no effect at all. If we break AgNO3 into pieces, we'll end up with Ag positive and NO3 negative. Neither of these are in the reaction. However, one of the properties of Ag is that it can react with OH. Ag positive, when it reacts with OH negative, will make a new compound. That compound is silver hydroxide, AgOH. Now this reaction is very favorable. In fact, it's more favorable than the equilibrium. Therefore, we are going to produce a lot of AgOH. The upshot of producing all the AgOH is going to be that we're going to remove all of the OH from the system, and therefore we are removing something from the right. And Le Chatelier's principle tells us if we ever lose something from the system, we'll react toward it. Therefore, in this case, since we have removed OH by using the Ag, we react toward the OH and we'll shift right, again making more product. Another unclear example for some people is adding water to the system. We might notice that water is indeed in the system. Your first instinct might tell you because you're adding water, you're adding something to the left. And your instinct might tell you that since you're adding something to the left, you'll shift away from it, and you might think you're going to shift right. But in fact, in this case, you will not be shifting right. And the reason for that is that pure solids and pure liquids do not impact the equilibrium. Therefore, even though it looks like we'd shift right by adding water, in fact, we do nothing at all. The addition of water will have no effect and we will not shift either way. Therefore, be careful to always check the state of the thing you're adding. If you're adding solids or liquids, those will not affect the equilibrium and you will not shift. Thank you for watching. We'll see you again soon.